Welcome! In today's video, we are going to talk about SAR satellites and the NISAR satellite. To study Earth, the planet we live on, we need synthetic aperture radar, or SAR satellites. These satellites provide high-resolution images from a resolution-limited radar system. The spatial resolution of radar data is directly related to the ratio of the sensor wavelength to the length of the sensor's antenna. For a given wavelength, the longer the antenna, the higher the spatial resolution. From a satellite in space operating at a wavelength of about 5 cm, C-band radar, in order to get a spatial resolution of 10 m, you would need a radar antenna about 4,250 m long. An antenna of that size is not practical for a satellite sensor in space. Hence, scientists and engineers have come up with a clever workaround: the synthetic aperture. In this concept, a sequence of acquisitions from a shorter antenna are combined to simulate a much larger antenna, thus providing higher resolution data. Some of the satellites include Terra SAR-X, Sentinel-1A, Tandem-X, and the NASA ISRO NISAR mission will measure Earth's changing ecosystems, dynamic surfaces, and ice masses, providing information about biomass, natural hazards, sea level rise, and groundwater, and will support a host of other applications. NISAR is the first satellite mission to collect radar data in two microwave bandwidth regions, called the L-band and the S-band, to measure changes of our planet's surface, including movements as small as centimeter. This allows the mission to observe a wide range of Earth processes, from the flow rates of glaciers and ice sheets to the dynamics of earthquakes and volcanoes. NISAR is planned to launch in 2024 from India's Satish Dhawan Space Center in Sriharikota, India, into a near-polar orbit. NASA requires a minimum of 3 years of global science operations with the L-band radar, and ISRO requires 5 years of operations with the S-band radar over specified target areas in India and the Southern Ocean. It uses a sophisticated information processing technique known as synthetic aperture radar to produce extremely high-resolution images. Radar penetrates clouds and darkness, enabling NISAR to collect data day and night in any weather. The instrument's imaging swath, the width of the strip of data collected along the length of the orbit track, is greater than 150 miles, 240 kilometers, which allows it to image the entire Earth in 12 days. Over the course of multiple orbits, the radar images will allow users to track changes in croplands and hazard sites, as well as to monitor ongoing crises such as volcanic eruptions. The images will be detailed enough to show local changes and broad enough to measure regional trends. As the mission continues for years, the data will allow for better understanding of the causes and consequences of land surface changes, increasing our ability to manage resources and prepare for and cope with global change.